LPGSI France, which has manufacturers of gas generators. Under the Suntech brand, we have Gilson, we have GL Sciences, we have Gilson from USA, GL Sciences from Japan, and Flon, a company from Japan, Hydrocell columns from Japan, Tohoku, a chemiluminescence company from Japan, again Bungo Kopi, a parent company of Jasco Corporation, that is also we represent a spectrophotometry company. Also we have young companies like Biochromato, Micro Emission, Lilac Pharma onto this liquid nanoparticle, which is upcoming thing, liquid nanoparticle formulations. So our brands representations vary from very startup companies in Japan to very established companies like Jasco. Since we are in the market for more than 35 years, we have good contacts in Japan, and many people are coming regularly here. The main advantage of Anatech is a good relationship between the principals and the company. So your problems can be easily handled. This is our product range, looks very big, almost 50 different products we handle. We handle from Jasco, we have different type of spectrophotometers. From Geo, we have mass spectrophotometer, XRS, handheld Raman, bigger equipments like Raman to a small columns or consumables. Also, we are into consumable industry also, like SP cartridges from GL Sciences. For the specifically, since the seminar is on the food industry, I would like to put our products which we supply for the food industry. We have UV spectrophotometer, as I was telling, almost 20 years back, 24 years back, we supplied to food system, and more than today about 2,000 UV spectrophotometers has been installed in various departments. Also, we have FTI spectrophotometer. Again, in the government, all Tamil Nadu state government laboratories uses the Jasco spectrophotometer, Jasco FTI. In all the 6 laboratories, they use Jasco FTI. And to addition, we have a Jasco FTIR with a microscope. So now there are many new applications are coming, like microplastics, which our Dr. Jagan will explain. So that type of analysis, we have a system called a microscope with FTIR with a microscope. Also, we have a fluorescence spectrophotometer. We have HPLC, UPLC, also an FSC. Also, we have Raman spectrophotometer. Also, we have a polarimeter, which is a commonly used system. We have supplied to King Institute also here. Also, this is very interesting system, a series spectrophotometer. In the recent days, now there are many applications coming on this. Dr. Jagan will put your light on that. From Geo, we have a single quad mass spectrophotometer, which most of you know, which is used for pesticides analysis, residual analysis. We have triple quad. Again, another very specific system called AccuTop, which is a high resolution top mass, GC top mass, which is a unique system. We have LCMS also, which is called this one, direct dot analysis. So this is not only just LCMS, also this can be LCTOF. This can be used as a dot analyzer. Mostly, many times without any sample preparation, directly you can keep your sample and analyze the mass. Also, we have multi-spectrophotometers for protein and other analysis. For material science, we have fluorescence spectrophotometer, X-ray fluorescence spectrophotometer from Geo. From Gilson, we have a positive pressure manifold for basic SPE, which our Govind San will explain. We have also automated system 241, which is a single pump system. For a larger sample, we have GX271, and for a large volume, we have 274. We have different variety. One is sir was telling whether it should be affordable. So we have a wide range of system to suit your requirement as a budget. We can fix your systems. From GL Sciences, Japan. Again, GL Sciences is a Japanese company. Everybody must be knowing about the inert cell column. They were the manufacturer for inert cell. So this company also manufactured other items. There are a wide range of consumables for HPLC consumables, GC consumables, SP consumables are produced by them. We represent them for their instrument. Other than columns, we distribute everything from them. We have, as positive out there, here we have vacuum manifold also from GL Sciences for a very simple SP systems. Also we have HLB cartridges. Most of you must be using Waters YS like that. So this is an equivalent SP cartridge, which is almost, the cost wise is very, very effective. And also a wide range of SP accessories, starting from adapters to a tubes, wide range of the GL Sciences provide, all that are available for you. Again, as I was telling, Biochromoto is a Japanese company, very young company, and a very innovative company. They have come out with a system called a smart evaporator. Basically, most of us are using a rotary evaporator, which is a common evaporator used in the laboratories. This is specifically designed for two things. One is low volume, as low as 2 ml it can use, and also for high boiling solvents like DMF4 can be evaporated with that. So Dr. Jagan will put more light on this during this presentation. Also we have microplates, plate sealers, and also a slit seal, which is also a specific item by Biochromoto, where you can do the sealing, we can do the titration online with the microplates. We have gas generators from FDGSI, France. We have nitrogen, hydrogen, also ultra-zero generator. Also we can customize the generators according to your needs. Our clients, almost all state laboratories, food analyst laboratory in Tamil Nadu, Karnataka, Kerala, we have installed the similar in the system which we are going to show you has been installed in Darjeeling also, West Bengal also. Also, we have installed the systems in most of the central research institutes like IIFPT or Defense DFRL, against CFTRI. So most of the central universities, IITs, we have huge number of equipments installed, ICER. So almost all central government universities, we have a wide range of instruments. Again, our state universities like Anna University, Bharatiya, Bharatdasan, Central University of Tamil Nadu, all state universities also have JASCO products. Also, we have systems from SRM, PIT, private university. If you take private university, all reputed universities have our systems. Again, in a private food industry, if you take Adair Bhavan, we are supplied to Adair Bhavan, we are supplied to VVD, also Heidelina biotech companies. We have a wide range of customers, started from government, government university, private university, research organization. So we can do a good type of networking. There are many scientists who are working on JASCO products. We have a big range of publications available on the net, which can be shared with you. So Anatech is there in the market for a very long time. So we have very good number of data, installation base. So the main advantage of Anatech, it's its team. That this is a very old company, almost 35 years old company. So we have a very big team. This is our south team. We have almost 7 engineers in the south. In Chennai we have 4 engineers. We have our engineer station in Bangalore. In Chennai we have a full-fledged system for everything. We have a long market presence, more than 35 years. Almost all our customers are 100% satisfied customers. We normally say to the customer, whenever we go for a meeting, when customer asks for a reference, we say we use our user list. Our user list will speak for us. So you can talk to any of our customers, almost 100% satisfied customers. Again, we have a wide range of product. I said we have from consumables, small consumables to a bigger equipments. We have almost a wide range of product to cover all your laboratory needs. Also, a qualified teams. As I was telling you about the engineering team, all our engineers are trained in factory. For example, Gilson, we have a trained engineer for Gilson. We have every brand. As soon as our directors are basically from the background of service, so they were very keen on giving an after-sales service. When they started the company, the basic idea of starting the company is for giving a service to the system. So we have very good. Our service team is much bigger than our sales team. So our engineers also fully trained by the factory trained engineers. Also, we have best pre and post sale support. For pre-sale, we have Dr. Jagan, our application specialist. Also, we have an application laboratory in Mumbai where we have installed most of our equipment, for which can help you out in giving you a demonstration or to have a good discussion. Most of our products, if you see, are an application-based product. So for our application needs, we have a full team. Also, sales support regarding your budgets or your requirement, delivery, everything can be taken care by our sales team. Again, Anitech being not a very big MNC company, so we have very quick decision making can be done. Decision can be taken on any direction. So for example, if you go for a MNC company for a service, so you have to go for a system, go to some software. So here it is not so. You can call your direct engineer. The engineer can give you immediate support. So that is one of the key advantage of Anitech. Again, flexibility on terms, so we can be very flexible. We can help you out on any time. Readily available spares are readily available. We have a big warehouse in Mumbai, so spares are readily available in Mumbai. Almost all our products which we cover has spares readily stocked in Mumbai. Thank you very much. I will ask Dr. Jagan to continue now. So Dr. Jagan will start his presentation soon. Thank you.
Once again, very good morning, and thank you all for coming. As Mr. Naveen sir, VP presented about our company, I'm going to start my presentation on trading the foot analysis journey. Like, I'm sure all of you are into this foot analysis journey already, or in the process of doing so. So I'm just trying to help you, enlighten you about how we can help you with our product range. So that's the main idea. So my presentation would be basically to present an overview of foot and beverage analysis. Then chief category of analytes. I'm going to highlight our product lines based on some important analytes like microplastics, mycotoxins, then in nutrient testing, fats and oil testing, carbohydrate testing, proteins, amino acid testing, and elemental analysis, and of course pesticides and pollutants in the food materials. So this is what I'm gonna present. So let's dive in. Well, in the current data-driven global ecosystem, like our customers or people or society. In fact, they are flooded with a lot of data regarding food and food-related complications and many other stuff. Comparatively, we have an enhanced awareness among the public when we like scale back or look back some few decades back. Now, although the consumerism market has been very much driving the ecosystem, but still a lot of information that you people provide as food analysts is actually making a big change in the consumerism as well as policy making decisions, then also improving the industrial practices and economic. It also drives economic benefits and also like it gives a direction for the research and innovation. Now, previously, people may not have thought about fortifying food, and after problems of like malnutrition and relief, then people started working on fortification. Similarly, previously people were not into this ready-made food items and so on. So only the consumerism market actually driven such products. And similarly, data about our problem with packaged foods, especially Maggi, whatever, the noodle thing or your water bottles, from which we get this PHP and other pollutants, that is going to bring about a lot of health hazards. They are going to drive our food industry as well as research and innovations and everything. So definitely this particular explosion in the data is driving our community right now. And of course, all this thing, food analysis in India is regulated by FSSAI, you all know it. Now, FSSAI along with AOAC has made a lot of partnership effort, and this FSSAI actually gives up this methodologies for testing food, and most of the methodology that is adopted by FSSAI is actually from AOAC. So now recently, last year they have got into a collaboration, and this is going to manifest through a lot of training sessions and adaptation of new methodologies and so on. Thereby, it is going to improve our food analysis sector as it is. So, with this overview, I'm just going to go into discussing about the analyze. So, microplastics, it is now considered next to the ozone depletion phenomenon or global warming phenomenon that actually brought in a lot of buzz in the environment among the people about the danger, the gloom of the society, or it is going to bring about a major devastation to the society. It is such a big problem, microplastics. So microplastics, it is of that scale. Now, microplastics, they are basically small plastic particles or degradation of the plastics that we use. Now, basically, they are less than 5 millimeter in size, and they can go down to nano dimension also. So when they are in nano dimension, it is called nanoplastics. When they are in micro dimension, it is called as microplastics. That's it. So they can be found in almost everywhere. They are considered to be omnipresent now. So they can be found in milk, they can be found in water, they can be found in your noodles or any other processed food material, anything for it. Even the packaged material, plastics, the plastics used for packaging of the food or whatever it is, over a period, they leach out into the food material that is being packed into, and that actually reaches the human ecosystem, and therefore we have a lot of problems. So that is what is represented here in this particular slide. So this actually sums up the food chain of how this particular microplastics. Now, what is this particular microplastics going to do? Now, this particular microplastic is going to give rise to a lot of trouble. Like it can start with digestive disorders, then it can lead to liver toxicity, then reproductive toxicity, immune problem, cancer problem, and this is just a summary, and this is not the entire list, because the research into microplastics is slowly gaining. Probably in the last decade only people have started working on microplastics, and we don't have more data on microplastics and its effects. So people have come up with this particular research. Now, speaking about this particular microplastics, we don't have FSI, they don't have, according to their own FSI's own reports with the High Court of Calcutta, they say that they don't have a standardized methodology to analyze microplastics. So they are trying to adapt the methodologies that is from AOAC, and they are in the process of adapting it to the Indian standards. Now, we in JASCO, we offer different product lines that can help in microplastic analysis. Basically, this microplastic analysis can be done using FAR, and you also can use with microscopy, FAR and assisted microscopy, and we also can do with gas chromatography. So, these three products, now I'm going to talk about them. So this is our FAR 4X model with ATR. ATR is attenuated transmittance reflectance. So this particular attenuated total reflectance. Now this particular combination, they can give a good data about your microplastics. Now the one advantage about this particular instrument is you can directly put your sample on the machine without any pre-processing. Without pre-processing, you can directly put your sample and you can start visualizing the sample. You can record the spectra, and this particular spectra that is recorded can be matched with the associated software with the instrument. Now we have this advanced spectra search software that is coming along with this particular instrument for exclusive for microplastic analysis. And we also have a library for microplastic analysis. So a combination of this instrument and this particular software and library can provide you with a very good tool for analyzing your microplastic samples. Now this is the software panel that is showing how this particular spectra can be checked on with the help of your software suite. And with this particular software suite, you can classify the spectra. There are about say 40 different spectra that is that it can be matched with, and with that basic classification you can also put for rigorous analysis with your library matching, and that can give you a proper identification of the microplastics. So this can be done with this particular instrument. Now going to this particular microscopy. Now this particular FDR microscopy provides, we have in JASCO, we have two microscopies. One is FAR microscopy as well as Raman microscopy. Both can be utilized for visualizing microplastics. Now, the advantage here is you can directly measure the size of the material, as well as you can quantify the microplastics, and as well you can document the shape of the microplastics here in this particular instrument. So these are some of the salient features that you can get out of this particular microscope. Of course, this particular microscopy is gonna come along with an FTIR attached here. Now, this particular spectra is from it is a this sample. Now, this is the sample that is mounted on this particular instrument. Now, in the previous slide, I said that you can mount the samples directly on FTIR, ATR. So, but here you cannot directly mount your sample. So, what you have to do, you have to basically filter out the microplastics from your food matrices, and then only the filtered microplastics can be analyzed using this particular FAR microscopy. Now, this particular FAR microscopy can provide you the data. This is the real time, this is the bright field image. Now, this particular bright field image can be now spectrophotometrically analyzed, and this gives a spectra. Now, in this particular mixture, you get different combinations of plastics here. You have PET, you have PE, you have PP, then you have polystyrene, and so on. So, all this can be analyzed, and it can be matched with the spectra that is coming along with the software. And the use of this microscopy is, it can, in real time, it can show you which of the particles is PE, which of the particles is PS, which of the particles is PET, and so on. So this particular blue line, it is from PP. Now this particular region is now polypropylene. Now the red color thing which is PE, polyethylene, is present here. And similarly, you can locate here microplastics and whatever plastic is present where, so you can locate them, and that is one big advantage with this particular microscope. Now, this particular microscopy, both are FAR microscopy and Raman microscopy, they come up with some of the key specialty here, like IQ mapping. IQ mapping provides you a facility to document a particular spot in your sample in both the technology. Now, whenever we remove the sample from one instrument and put it back into the other instrument, we will not be able to focus the same spot. So, for avoiding this particular problem, JASCO have come up with this particular IQ mapping, where you can analyze the same spot with both the instruments using this IQ mapping. So, this is all inbuilt, which you can use from this particular microscope instrument. Now, how do you choose which technology you have to use? Now, as I said in the previous discussion, I said if you're going to analyze your food matrices without any separation or without any processing, you have to go for FAR. If you're going to do it with separation, then you have to go for a microscope. Fine. But why to separate and why not to separate? Now, this is again a question. Whenever you have a larger molecules, now larger molecules are easy and they can be easily visualized. And this FTER ATR, the previous instrument, what I spoke about, it actually helps you to analyze microplastics which are about 5 millimeter, less than 5 millimeter to 50 micrometer dimension. So it cannot visualize or it cannot help you analyze any microplastic which is less than 50 micrometer. Whereas particular instrument gives accurate mass analysis and is exceptional for structural analysis of unknown substances. Most of the microplastic samples we get out of food matrices or environmental samples, they are often a mixture of many different plastic residues. In that sense, identifying them, and in nature also they are a degradative product. So to identify them, this particular GC chromatograph with pyrolysis is a very good tool. And high selective quantification of moving to high mass resolution is possible, and it has got a wide ionization methods that gives you that provides you with a lot of detectors, opportunities to use lot of other detectors, and it has also got potential to extend the instrument into two-dimensional GC, where you can like concatenate two GCs together. That actually improves the sensitivity. Now, with this, I'm just going to the other analyte. I'm focusing on mycotoxins. Now, mycotoxins are derived from fungi. They are food spoilages by fungi lead to formation of mycotoxins in several foods. Now, what is the problem with this particular mycotoxins? Mycotoxins, they bring about a lot of health disorders. Like, say for example, everything it starts with your problem with your alimentary canal, digestive problem, and it goes up to your liver toxicity, cancer, and so on. So, very commonly, this mycotoxin contaminations have been found in almost all the food materials. Now, they have been found in cereals, they have been found in milk, they have been found in pulses and beverages, and so on. So, identifying the mycotoxin level in the food is something very, very important. Now, Now, analyzing the mycotoxin comes with a problem of separating the mycotoxins. So, for separating the mycotoxins, you need to use appropriate columns, like either microcep columns or Aflatoxin columns. These are some of the columns widely used for mycotoxin separation, and you have to go on to derivatize them. Now, microderivatives, of course, being an analytical area, we might be knowing that not all the analytes would be visualized in the same column. So, in that sense, we are going to derivatize them. So, normally, the common trifluoroacetic acid derivatization is quite easy, and it can give you a good result of mycotoxin analysis. Now, these are some of the mycotoxins I have listed. There are a huge number, more than 1,000 mycotoxins are available. Now, these are very common. Aflatoxin is a toxin that is very prominently produced by Aspergillus species of fungi. This Aspergillus species is very commonly infested in your peanuts or your onions and so on. So, most of the onions, whenever we take up and see a black color stuff, could be an Aspergillus or mucus. So, definitely such an aflatoxin is very common in the vegetables or whatever we are going to use, there is a possibility. So, to detect the mycotoxins and to limit their level, so we are going to use HPLC and UHPLC from JASPO. This particular HPLC and UHPLC from JASPO, they come up with very good features. Now, this SSQD solvent delivery system is something like slow suction quick delivery system. Now, this particular slow suction quick delivery system provides very stable flow rate, and it actually helps in proper resolution of the proper flow rate, helps in proper resolution of the material. Now, also this particular JASPO system comes with vertically drained systems to channel away solvents. Then also it comes with pioneering optical designs. JASPO JASPO products, they are specialists in optical design, especially in spectrophotometry. So this particular design is something very, very crucial, and they help in analyzing our product. They come up with different types of detectors, like fluorescent detectors, refractive index detectors, circular dichroism detectors, and many other. Now, this particular JASPO system, it comes with ChromeNO software. All our chromatographic applications comes up with this particular ChromeNO software system. Now, this is a software suite. It can adapt to the individual system. Now, again, it is readily customizable, and it can provide complete audit trial for instrument usage and performances, especially being in food lab. Now, we need to maintain an audit trial of all our activities. So, this particular software system will give you an added advantage of providing options for it. Now, this particular application, in this application, these spectra suggest that the aflatoxins were separated using the HPLC and using UHPLC. Now, when to choose HPLC and when to choose UHPLC? Now, whenever you want to reduce the solvent that are used in your HPLC, then you have to go for UHPLC, because UHPLC is comparatively rapid and uses much reduced solvents, and it also gives a better resolution. So the main difference is about the high pressure that is involved here in UHPLC, and this is a standard pressure that is involved in HPLC. So this chromatogram is from corn samples, and this chromatogram is from peanut sample. Now, all this sample, from this sample, aflatoxins of different types have been separated. G1, B1, G2, B2, all are separated, and that is being reflected in this particular chromatogram. Now, moving on to nutrient testing. Now, we start with oil and fats. Now, according to the recent reports from FSSAI, most of the edible oil, a survey of the edible oils in India, about 2.42% of the samples failed safety parameters. Now, what is this particular safety parameters? What are they speaking about? Now, they speak about this presence of contaminants and presence of rancidity and so on. So again, this particular 24% it failed in quality parameters. Of course, again here the rancidity parameter comes here, and about 2.82% were misbranded and so on. So we have a lot of adulterations in the oil. Now, most of the vegetable oils, they are mixed with mineral oils, so that can bring about a lot of problems. Now, there are different grades of oils also, we know for sure. So apart from that, we also have a problem of aflatoxins in oils. Now, most of the sunflower seeds or your groundnut seeds, they may be contaminated with aflatoxins, and that can be also big problem about this safety. Now, this particular analysis of fats and oils, they prominently use UV visible spectrophotometer and fluorescence spectrophotometer. Then you can also use DC analysis for FAME. Then you can also use DC stepping along with MS. Now these are different instruments that I'm gonna talk about. Now, so this is about an FE 8050 spectrophotometer from JASCO. Now this is the instrument, and here the application here is they are trying to test the quality of the olive oil. Now they have tried with different, there are two different grades of olive oil here tested. One is extra virgin olive oil, the other is pure olive oil. And they were trying to analyze the sample with the fluorimeter. Now this particular fluorimeter, it analyzes the fluorescence property of the sample. Now in the oil there are two important constants which can give rise to fluorescence. Now here one is vitamin E, the other is your chlorophyll content. Whenever you extract the oil from the oil seeds, there is a good possibility that you can have your chlorophyll content carotenoids that are passed down to your oil extract. So all the oils will have this particular chlorophyll content as well as your vitamin C. So this particular fluorescent molecules, when they are analyzed in your spectrophotometer, now they are going to give different fluorescence intensity. Now this particular this is the resolved spectra. Now this is the unresolved spectra. Now this resolved spectra here, this particular region, the fluorescence that is appearing in this particular region, it is of the chlorophyll, and the fluorescence that is appearing in this region, it is of your oxidized vitamin E. Now, based on the quality and the intensity, based on the intensity of the fluorescence here, we can grade the oil whether they are pure or extra pure, or we can classify them whether they are high grade or low grade or medium grade and so on. So such an application is made possible with this particular spectrophotometer. Now this particular plot is a summary of the analysis. They have multi-component analysis. This is PARAFACT is a parallel factorial multi-component analysis things, where they have tested a total of about 10 samples. Out of the 10 samples, all the extra virgin olive oil, they are all grouped together, and the pure olive oil, they had a different signature altogether, and they are grouped separately. So such a classification is made possible along with this particular spectrophotometer. So you can also do multiple sampling. That is also possible along with this particular instrument. Now conventionally we use UV visible spectrophotometer for analyzing oil samples, especially to test the color of the oil and also to test about the rancidity of the oil. So that is all a common application. So for that also we have UV spectrometers. We have a range of spectrophotometers from you can choose from 4 different ranges. So that is also available. Now, so this is the UV visible spectrometer I am speaking about. And apart from the conventional applications of measuring the color or rancidity and so on, we can also test, we can also use this particular spectrophotometer for another different application. Now, another big issue with the oil industry is mixing of reused oils. Now, the problem with the roadside wallas or roadside shops, they use reused oil from big food hotels or restaurant chains and so on. Now, the problem with this is, whenever we speak about oil, it should have a unsaturated fatty acids should be higher and saturated fatty acids should be low. Now, when you start heating the oil, the saturation levels actually increase. Unsaturation decreases and saturation level increases. Now, when you consume highly saturated oil, then it can lead to a lot of health issues, starting from digestive problems and even it will go up to cholesterol buildup and many other complications. So it can also highly reused oils can even lead up to cancer. So that is also possible. Now we can also use this particular UV spectrophotometer in this particular reflectance mode. Now when you use this UV spectrophotometer in reflectance mode, you can distinguish between oil with reused. You can use this particular application to distinguish whether the oil is pure from reused oils or whether it is impure. Like the basic idea here is like impure oil will have lot of suspended solutes in it, and that will give rise to a different reflectance pattern. Whereas pure oil will have a lesser reflectance pattern. So that is the basic idea. So using that, you can verify whether the oil sample that is tested is impure one or it is a pure one. So that is also possible. So this is the different application of our UV spectrophotometer. Now, speaking about oils, whenever we speak about oil, definitely the flame analysis is one important area. Like for flame analysis, GC with quadruple mass spectrophotometer is actually suggested. Now, this particular Geol brand, it offers a high sensitivity, excellent dynamic range. It has got an enhanced performance ion source. This actually helps in ionizing the fatty acids, and the photoionization and electroionization combination ion source. It's a two ion source. Now, two ion source gives rise to a better signal, and this better signal it gives rise to an increased signal to noise ratio, and therefore you have a better resolution of the sample. So, integrated quality analysis software, MS file analysis assists help in identifying the fatty acids that have been identified. Now, this is the spectra this is GC spectra, and this is the data, electroionization data, and this is what the photoionization data. Now, with this particular integration of these two data, you can very well predict the structure of the fatty acids. So, this particular instrument offers you a better solution for doing flame analysis. Now, apart from this, we have another interesting application. Now, most of the fatty acids are like they have a good smell or this odor. Now, apart from that, when we speak about any volatile compounds, like most of the citrus oils or any other oils, they have very good aromatic smell. Now, these aromatic oils, they can be identified. Whenever we go for buying some like axe oil or lemon oil and so on, there again there are a lot of adulterations, there are a lot of problems. So to test such aromatic oils and so on, we can go with this particular GC sniffing MS. Now, what is this particular GC sniffing MS? Now, this is gas chromatography with an MS component attached to it. Along with it, you also have a sniffing component attached to it. Now this particular sniffing component, whenever you inject a sample through your GC, you get and it is resolved, you get a peak with your mass spectrometer. And whenever a peak is being formed, it will give a signal out so that you can start the person in charge of analyzing the sample can use this particular transfer line, sniffing line, to sense that particular molecule. Now, as a mixture, you smell, it would give a different smell altogether. But when you separate them into different fragments and when you start smelling them, probably you can identify them properly. So for that, this particular application is useful. So this particular GC sniffing MS is for that application, and sorry, Geol is coming up with this particular application. Now, moving on from fatty acids and oil, we are stepping into carbohydrates. Carbohydrates have been known to be part of all our foodstuffs, and they are utilized in very different forms for various other reasons. Some of the reasons are listed here. So they are used for functional attributes. They can be used for increasing the sweetness, viscosity, bulkiness of the substance, solubility, or to give consistency to the food material, or to give texture, body, or browning capacity, and so on. So they are used for many different varieties, and so on. And we also have a lot of sugar substitutes in the markets, and these are used called as food additives, and there are a lot of problems with food additives recently that have come up to fore, like continued use of food additives could turn out to be carcinogenic and so on. So WHO has recently flaunted such an information, which was again reassessed by FSSAI, and FSSAI said that we cannot put a blanket ban on all the sweetness. We have to go on by case condition, and therefore they are in the process of developing new guidelines for working with sugar substitutes like sweeteners. And apart from this, a lot of recent reports regarding this sugar additives in food materials also have come up. FSI recently notified that whenever food juices are being mixed with sugar or sugary substances, it has to be notified. We cannot claim it to be 100% real juices and so on. So that has to be said. So a lot of things. Even there was a notification regarding food for child, like children supplements should not be added with sugar unless and until it is very, very mandatory and so on. So a lot of guidelines are coming up regarding carbohydrates, and therefore you have a very big scope for carbohydrate testing. So conventionally, apart from all these things, calorie-based consumptions also demand proper labeling, and for that again we are doing carbohydrate quantifications and analysis. So this carbohydrate-based analysis normally use polarimeter, HPLC and FDR. So in our product line, I'm gonna speak about JASCO's polarimeters, HPLCs and FDR. Now, JASCO offers the digital polarimeter P2000 series. This particular polarimeter has got a high speed precision and accuracy, and it has got a long life polarizer. When we compare it with any other product in the market, it has got a very good life, and it has got an ultimate flexibility, and it has got validation programs for GLPs and GMPs, good laboratory practices and good manufacturing practices, and it has got a very good software system that gives advanced control of the instrument. Now, what this particular polarimeter helps us to do? This particular polarimeter helps us to measure the angle of polarization. So, test whether the carbohydrate is a D-carbohydrate or a dextrocarbohydrate or a levocarbohydrate. So, that particular, we use polarimeter to analyze the optical rotation potential of the carbohydrates. So, with that we can categorize, because most of the carbohydrates D form may be potentially useful, and L form can be toxic also, or it can be of no use or no utility also. So we have to identify which particular isoform of the carbohydrate is present in our sample. So for that reason we use digital polarimeters. Now apart from that, we can also use high performance liquid chromatography HPLC in ELST mode. Now this particular carbohydrates, they have they cannot be investigated under UV. They don't have that particular UV absorption range, and therefore we go with a different UV. We don't go with UV detector. We go with a different detector. Now ELSD detector. Now this particular ELSD detector, they help in detecting the sample. Now this particular chromatogram, which suggests the standard mixture of sugar alcohols, xylitol, mannitol, inositol, and mannitol. Now this particular sugar alcohols, they are called as sugar alcohols. These sugar alcohols, they are probably used for increasing the texture and consistency of the material in the food. So they don't directly give rise to the sweetness of the food, but they are used in for other functional attributes of the food. So this is done with your HPLC, and the same could be done with this particular chromatogram is showing the separation of mixtures of cyclodextrins. Now cyclodextrins is again kind of artificial sweetener, and it can also be used for your increasing the texture of the food. So such food material, carbohydrate materials can be analyzed with your HPLC. Now, it can also be, this FDR ADR spectroscopy can also be used to analyze the composition of the food. Now, what are all the different types of carbohydrates present in the food? Now, speaking about this, now in the previous cases, we actually these are destructive methods of analysis. This polarimeters or your HPLC, they are all destructive methods of analysis. You extract the food from its matrices. You extract the carbohydrates from the food matrices, and then you subject them to analysis. Now, moving to this particular FDR ADR spectroscopy, this particular application, this particular instrument can be used for an application where you don't destroy your food. You can directly put your food on the instrument and you can start analyzing it, and you can get a good idea about what are the different carbohydrates, like your monosaccharides or disaccharides or polysaccharides that are present in the food. You can directly get the information out of this particular instrument. Only thing is you have to get the spectra matched out with the digital library, and you have to interpret the data. So that's it. So here I've just given an example here. Now this particular food material, it is made up of like sabji or like this is like salad. Let us consider this is a salad. Okay. Now we are going to test what is the carbohydrate composition of this particular salad. So you directly now all the plant materials they have complex carbohydrates. This complex carbohydrates, they are present in their cell walls and so on. So all the complex carbohydrates, when I speak about it includes your secondary, a cell wall. A big cell wall is there where you have your polysaccharides, you have your monosaccharides, you have disaccharides, and many oligosaccharides and so on. So all this can be analyzed, and the information about their spectra is being presented here. Now this particular spectra, it is pertaining to xylem. This is pertaining to arabinase, arabin. This is mannan. This is fucin. This is galactan. This is glucan, and this is ramenose. This is galactan A. So you can get a different spectra for different monosaccharides, and you get all. This is a spectra of monosaccharides. So similarly, you can get a spectra for polysaccharides. So integrating all the data together, you can come up with what is the percentage of carbohydrates that is in a polysaccharide. Now polysaccharides, they contribute to fiber content of the food. So you can label it as fiber content of the food. All the polysaccharide information can be grouped into that. And monosaccharides, they contribute to the sweetness of the food. So all that particular monosaccharides can be grouped into like sugar content of the food. So such information could be obtained by analyzing your food using this particular FAR spectroscope. Now moving on, regarding protein, of course we know protein are the building blocks of all animals. Now everybody has to consume adequate amount of proteins for a healthy life. FSI has investigated the food samples in the protein samples or the protein products that are marketed in our country, and they have come up with about 30,053 civil and 4,817 criminal cases in 2022-23 alone. So most of the problem is either the sample is not conforming to the standards, they are contaminated. Proteins, they can be easily contaminated. They can be easily inviting microbial growth on it, and therefore it can be easily contaminated, and it can have a lot of, so consuming mushrooms, normally we take mushrooms as a source of protein and fibers. Now this particular mushroom, if you are not eating it within a day of its preparation, then it is going to turn out to be toxic because of the growth of the microorganisms. So such microorganism contaminations in protein samples is very common. So FSI have come up with such problems, and a lot of cases have been filed in that particular area. Now, about 70% of the 36 popular protein supplements sold in India are mislabeled, and 14% contains toxins. So, investigating proteins is something very, very important as a part of our food analysis. Now, conventionally, apart from that, we also have new sources of proteins. Very interesting ones are insect-based proteins. These are old-phase concepts. Like people in olden days, they used to eat a lot of small insects like easel and so on, like as a source of protein. Now people are again picking it up, and people are coming it as insect-based proteins, and it's going to be used as feed as well as for food. Normally for rearing fishes or chickens and so on, insect-based foods are being propagated. And similarly, fungi and algal-based protein supplements like spirulina capsules and so on, so they are also being marketed now. So all these are new sources of proteins, and they all need a lot of analysis and investigations. So to study about the proteins, there are different strategies. conventionally we go with what is the quantity of the protein. So for doing quantity analysis, we normally go with the UV analysis, like do with this one, Bradford's method or your Lowry's method or your any other method, be it bizincholic acid assay method and so on. We adopt different strategies for quantifying proteins. So this is a very common application. Now, apart from that, we can also do protein analysis using UV for microsamples. So microsample, like say for if your sample volume is very, very less or something like that, then you can go on to do with a single drop analysis, where you can exactly quantify your protein concentration in just a single drop of it, maybe like 1 or 2 ml of it. And normally and this is, we are using a spectrophotometer to do it instead of a nanodrop. So this is going to give you a better result than your nanodrop analysis if at all you are thinking about doing it in nanodrop. So this gives you a better analysis. Now using this particular single drop analysis, you can also quantify not only protein, you can also quantify your nucleic acids and so on. So that is also possible. Now this particular application, this is a result of an application of quantifying your protein sample through the single drop analysis method. Now moving on, we can also analyze the quality of the protein, whether this particular protein is properly folded or improperly folded and so on. Very commonly we come across like insulin. Now insulin that the diabetic patients use, they are hexavalent insulins. They are mostly thermostable. Now whenever this particular thermostable insulin has to be injected, it is getting converted into monovalent insulin and only then it acts on. So there is a change in the conformation. Only when a correct conformation of the protein is present, the protein is active. When the protein is not in the correct conformation, then the protein will be detrimental to the body also. Now, speaking about detrimental to the body, have you people come across concepts like Alzheimer's, Parkinson's, or these two, for example, instance, Alzheimer's and Parkinson's, they are not caused by any other problem, they are not caused by any pathogens, they are not caused by any microbes, they are caused by your own proteins. The misfolded proteins that is getting accumulated in your body, that actually leads to this particular problem of Alzheimer's and so on. So this is about misfolded, folding of the protein. So I am stressing upon this folding of the protein because if at all you want to analyze the folding of the protein, CD instrument is the appropriate instrument to analyze the folding of the protein. Correct conformation of the protein can be analyzed using CD instrument. Now, it is circular dichroism instrument. It is circular dichroism. CD stands for circular dichroism. Well, PDA is a detector. So similarly, here we are using CD detector. Here we are using this particular CD as a detector here in SQL.
So basically an optical activity of the compound. So what we'll do is this CD detector basically finds the left and right polarized this one, and they find the difference between the left and right polarized light. Is a phenomenon called a CD, circular dichroism. With that you can able to find out the protein secondary structure. Basically secondary structure or tertiary structure of the protein can be analyzed.
So CD as it is a different instrument altogether. Now here we are using that particular property as for a detector. So we are trying to adopt CD as a detector here. So we can contaminate this particular HPLC and CD together, and using that you can analyze the quality of the protein.
Just I want to say something about it. Basically what happens is this optical isomer, they exist into two enantiomeric forms. So this, for example, we use one compound as a drug, but actually that drug has got two enantiomeric forms, and one of the enantiomer may not be really drug, but it may be toxic also for a body. So in such case, CD detector, which is circular dichroism detector, it differentiates between the two enantiomers and you can estimate. So in HPLC you separate the product, you separate the enantiomer, and you actually detect with the circular dichroism detector. And that work chiral chemistry is very popular now in all the drug industry because they isolate from the racemic mixture the important component, important or maybe useful enantiomer, and toxic enantiomer or unuseful enantiomer, they remove it by chiral separation. Thank you.
JASCO is one of the, it's only available with JASCO only.
This is amino acid profile.
Well, this is an amino acid profile, but
Some compounds actually the PDA wave one is different way. Wave one is some compounds this isomer based
this particular chromatogram is what you have said. It is the chromatogram showing the peaks of an amino acid. The amino acids are derivatized by Dapsel amino acid derivatives. So with that we actually try to see the pattern of the amino acid that is present. This is one aspect of it. The second aspect of it with the CD detectors. So this is, let us say, one is cysteine, that is cysteine. Yeah, cysteine. 17 is cysteine. Now this is 17 cysteine. Okay. Now this particular cysteine, there is a portion of it that is existing in D-cysteine form, and there is a portion that is existing in L-cysteine form. So you can quantify which particular amino acid is present in which particular form, because your L-cysteine will be used in your body for building up your protein, whereas D-cysteine will not be utilized in your body for building the protein. It cannot be metabolized by your body. So therefore, to analyze the quality of your amino acid content or your protein content, we need a CD detector. So this is here we are analyzing the amino acid profile. So earlier I spoke about protein, but from protein we get amino acids. So proteins are nothing but building, they are built from our amino acids. So we are testing our amino acids and we are testing its optical property, whether it is D form or L form. And if it is enriched with L form, then it is good for consumption. If it is not, then it may not be good for consumption. So that's the idea. So this is one application.
So this particular detector can give you both UV signal as well as CV signal. Single detector, you can take the UV signal also. Yeah.
Maybe he has a question that there is a different instrument called CD polarimeter, and there is a detector like a PDA or UV detector or RI detector which can be clubbed with HPLC. Now this particular chromatogram which he is showing, where HPLC connected with the CD detector. So JASCO can offer both CD detector as well as CD spectrophotometer. And as sir said, some of the enantiomers are very toxic or poisons. So in new medical chemistry field, this is very important to find out which is poison to be removed and which is very, very helpful to eradicate the disease. So this is getting very popular in pharmaceutical company also, apart from food. Thank you.
I think this chromatogram, what you showed is the dapsel chloride derivatives, right?
Yes, sir. That's the
Of
chloride.
different amino acids.
Yes, sir. That's the chloride.
And the typical
derivatives.
HPLC with UV detector.
Yes. So right. So as sir said, this is the additional compartment here. This is the HPLC compartment and this is the CD detector compartment, which you can integrate with the HPLC and you can get this particular data. If you're not integrating this compartment, you will get only this data. So that's why we have this combination, HPLC, CD detector combination. So we have to compare it with standard. We have to construct a standard. We have to calibrate with along with the standard. Only then we can quantify it. No, we get D system also. Yes.
You get a standard mixture.
Dapsel chloride.
I think Sigma also gave.
Yeah.
Sigma also giving.
So the name answer would be for D system, D align and so on. And if at all you want an L variant, you can get that particular variant and you can go on. Thanks. Thank you. But we can also analyze proteins with FAR. Now, again, whenever I speak about FAR, you have to think in mind that you are doing a non-descriptive analysis. You can directly put your full matrix onto the instrument and we can get the data. Now here, what is shown here, it is a food matrix. We have tested milk. Now this particular red line is a spectra for the milk, and this is blue one is a milk with coffee. So coffee powder. So you can see the distinction between them. Now this particular region is for the protein and this particular region is for the sugar. So when you compare the region, you can get what are all present and what not. So this is just a spectra. To get a meaningful data, you have to submit it to another analysis, rigorous statistical analysis, which is called the PLS calibration model. Now with this we can actually quantify it and we can compare the samples between whatever you want, like between milk as well as your coffee and so on. So this particular FDR instrument, it comes with a good software support to help you do with this particular PLS calibration also. So this is, you can do it with in a non-destructive manner. And again, this particular spectrum is near infrared spectra of food samples. Here the food sample they have tested is cheese. They have tested different grades of cheese, and they have tried to study the different composition in the cheese. What is its protein content, what is its fat content, and so on. So again, from this we have to do this particular, this is partial least square calibration, we call it, PLS calibration. So if you do that, you can try to estimate the composition of your food material without any discussion. You can quantify your protein sample without any discussion. So this is also possible. This is what we have been speaking about. Sirs have been telling you about circular dichroism polarimeter instrument. So this is the instrument, circular dichroism spectrometer. Now this particular instrument, JASPO is the leaders in circular dichroism. So here I'm just gonna talk something about an application about how to testing the food contamination. When here the application speaks about time estimation of test contamination. See, normally when we pack process of food, say for cereals and so on, when we pack a food grain, during the package period, if the food grain is contaminated or infested with the pest, then it is one thing. Or during the storage period, or during the transport, or during the consumption period, it is contaminated. We don't know for sure. Imagine a consumer is coming with the problem. Come on, I opened up this particular food jar and it is infested. He is claiming that he is going to the court or contesting the case in the court or something like that against a particular food company. Now the food company want to, the oil manufacturers want to test where is the problem. So they can test the food material to know whether the food sample was infested during the processing and packaging stage, or whether it is being infested during the utilization stage. So they can do it using this particular circular dichroism. So this such an application can be done. So whatever I spoke about is a very, it is not for the commoners, it is for the company, but it can be brought down to commoners usage also. But speaking about this one, now this is the contamination during the processing stage. This is during processing stage, they do heating and lot of processing. So what happens here is, now whenever an insect infests a food material, it starts digesting it. So whenever it starts digesting it, then the insect is going to grow, right? So the insect protein is going to increase in quantity. That's it. So whenever the insect is going to grow, it is protein content is going to increase. And when you compare with the protein content of the insect and with the sample, it is going to be different. So what they are trying to do is, they are trying to analyze the they are trying to look for a protein of insect origin. Now if the insect origin protein is present during the samples in pre-processing stage, then it is confirmed that the problem is during pre-processing itself. So food itself is spoiled, and without quality control they have been passed on. So the company has to take the blame. But if the during the pre-processing stage, they did not detect any insect-related protein, then the food company is exempted from the case because it is not with them. So during the utilization, they might have opened up, that could have resulted in infestation of the fish. So that is also possible. So what is the protein they are looking for is, now they are trying to look for a myosin protein. Now myosin protein of insect origin, so they try to look into it. Now this particular blue line, this is about your from insects, and this is standard myosin, so they are trying to compare. So both they have a similar pattern, so they are trying to quantify it. So this particular chart gives you the structural data of your protein. So what percentage of the protein is in alpha helix, what percentage of it in beta sheet, and what is in beta turns and random coils and so on. All of this contribute to the structure of the protein. So whenever you speak about a protein in its proper structure is functional. So protein in its improper structure, it is non-functional. So they test for the actual structure of the protein of this particular myosin, and if they try to quantify it, and with that they try to come up with the data saying that this is infested during the pre-processing stages or this is infested during the utilization period and so on. So such an application is possible. So this is with circular dichroism. There are a lot many applications with circular dichroism. So this one application I found it to be very relevant to food industry, so I just came up with this one. So with this we move on to elemental analysis with XRF. Now of course this is XRF, it helps in identifying the nutrient metals and also about contamination with heavy metals and so on. So all such analysis could be done with this particular XRF from Geol. Now this is a peak of different elements that is present in the sample, and you come up with a dynamic software, and this particular software helps in simultaneous analysis of elements as well as quantifying from ppb to 100%. I mean ppb is a different standard, I mean 100% is different. So you can quantify in any particular range, and you can get all this thing done within a very short period, maybe within a 10 minutes period you can complete the entire analysis. So what is the other alternative for elemental analysis? Normally we go with atomic absorption spectroscopy, or we go with ICQMS and so on. So all those things need very elaborate sample processing steps and so on. This particular elemental analysis with XRF, they come with a very minimalistic sample processing. Actually they don't need any sample processing. They are non-destructive analysis, like the previous case I spoke about FKA. So here also it is a non-destructive analysis. It supports analysis of solids, powders and liquid samples. So these are some of the salient features of Geol XRF. So this could also be one important addition to your food labs. Now apart from this, speaking about the pesticide residues, now yes sir.
Elemental.
Metal, yeah.
Yes, sir. Because it is small.
Well, whenever you put a piece of salt, you can analyze a piece of salt.
See the limit of
Detection.
FSSI or EAC, their reduction is very low, 5 ppm, 5 ppm, that much in oil.
Okay.
So how it can be your exercise?
Now this XRF offers you, it has got a dynamic range. It offers you potential to quantify in 0.2 ppb, sorry 0.1 ppb to 100% levels. So it can actually.
Instrument can detect the ppb.
That,
ppb means MS. Percentage means you have to come to AS.
there is an option in the instrument.
XRF is a significant.
Yes.
You can screen.
Yes.
Different type of grades of metals.
Fine.
You can screen.
Yes.
That cannot be exact.
Yeah, screening it.
Also, you have
And it can give you an
Idea.
idea about what range it will
The
be.
idea is suitable only for screening. You can segregate. You cannot come to a conclusion. That is not a result. You can screen.
Well, I can talk on this particular thing probably sometime later. I'll discuss with my principals.
It's not meta-analysis now.
I'll discuss with my principals and I'll get back to you on this particular.
There are some papers published by Geol on this,
This-
food related to food element analysis. We will share you the papers.
There is an
Yeah.
XRF, there are different type of samples, the DDXRF.
This is a EDXRF.
EDXRF.
This is a EDXRF basically.
The EDX.
DDXRFs are there, but
Yeah.
generally for mineral analysis.
Yeah,
Mineral
this is
Yeah,
a
right.
EDXRF basically.
Course and all, that they can do it.
Yeah. See here actually the principal Geola has given a application note on this which we will be circulating to you along with the booklet. On that this is mentioned. I think they have done some analysis related to Japanese fooding agencies regulator according to them.
There's no sample analysis preparation actually, so sample can be put. But
Yeah.
you are right that
Most
metal,
XRF is mainly 90% for
mostly
metal,
foundries
metal
and
analysis.
zinc and metal, like they use it. But also some application will share with you.
Yeah, there are some small applications are there available.
DRI people they will use it.
Huh.
Not food.
Now,
We will supply you, sir. We have that. We will on the booklet. We will give you the application notes.
Well, speaking about pesticides, we have been learning more about the pesticide contaminations in food, water, mother's milk, breast milk, and so on. So we know what are pesticides, what are its effects, and so on. So pesticide contaminations is a very big problem, and monitoring it is something very necessary. Now, normally the gold standard for pesticide analysis is again this one. Mass DCMS. Here, this particular geol instrument it provides you with the high sensitivity and high throughput. Short position cells with accumulation of ion, it gives you a better resolution. And variety of samples, pre-processing options is available. You can have direct injection, or you have an head vial injection system, and a lot of other pre-processing options are available. Again, you have a variety of non-GC sample index is also possible. Then you have your optimization tools. Then you have a dedicated software to identify and quantify the dioxins and the pesticides in your samples. So that is provided with this particular instrument. And it has got other powerful analytical tools like Esprimo and Esprem. So moving on, we also have GC from GL Sciences in Japan. Now they also offer high sensitivity and ease of operation on high performance electronic pressure and flow controller, auto injection, and you also have distinct injection ports for diverse detectors, promoter scales, softwares, and so on. So maybe for medium range applications, you can go for this particular. And speaking about smart operator. Now, this particular smart operators are very useful in getting your samples, concentrating your samples. If at all you have a very small samples and you want to concentrate it and so on. And if your sample matrix is highly polar and has got a very high boiling point, so in such cases you cannot use this particular sample in rotary operators because the sample volume is again very low, as well as the have high polarity and high boiling temperature. They are the design factors here. So for such samples, you can go with this particular smart evaporators. Now this particular smart evaporators, they offer you with the utility of using any type of wires, like ranging from Falcon, which is about 15 mm, to even your FNOF tubes. You can use any such wires and you can directly connect it to the instrument. Now the instrument, it has got a like screw cap. Now this particular screw cap, through the cap only, you have this particular vacuum which is coming in. This actually prevents the direct suction of the samples from the container. So you don't have a bumping of the samples. Normally, whenever you go with the concentrators, now highly polar solvents like water or any other substance, whenever you try to concentrate, we normally go with lyophilizers. Lyophilizers, they to avoid bumping, we actually pre-coat the containers into ice and so on. Only in ice forms we can do this particular concentration and so on. So such things can be eradicated here. So you can directly put your sample here and you can screw cap it, and through the ridges in the screws, the vacuum is poured into the instrument, and therefore you avoid the bumping and you achieve rapid concentration of the sample. So that is the main advantage of this particular smart evaporator. So again, we have a different range in this particular smart evaporators, starting with 1 vial smart evaporators to 10 vials. You can simultaneously do 10 vial operations also. So you can use this one for concentrating a very precious small volume and high boiling point samples. So, again, we also deal with GL sciences like inert cell HLD SPE columns. Now, this SPE columns are widely used in extracting your analyze from the complex food matrices. Now, the best thing about this particular inert cell HLD is they offer you potential to work with both polar and non-polar analytes in your sample, and they have a very good retention condition. This particular graph shows a comparison between the inert cell HLD SPE columns with different company HLD SPE columns, and we find better, almost a similar result with all the tested companies. And we also compare, this particular data also compares our inert cell HLD columns with the Waters Oasis HLD SPE columns. Now, if you look at the comparisons, now here the analysis is about the tetracyclines from chicken sample. Now, such analysis can be done from not only from chicken sample, you can invariably apply it to any food matrices, honey or any other content. You can apply, and you just have to extract it with this HLD and you have to quantify it. So quantifying it, normally we go with HPLC or you go with GCMS and you try to quantify it. So this particular data, this is from tetracycline quantification we did with HPLC, and these data they show that they have a almost equal performances, and this is economical and also have a better, good quality results compared to the Oasis, Waters Oasis HLD columns. So thanks for your attention, and if at all you have any questions, you are free to post. We will be happy to help you out.
Your sample. Quantification is possible with FDI. Also, JASPA offers different type of quantification software to do that. But it is always to be done at a transmitters, not with the ATM. Nowadays, see, now almost everybody started using FTR with the ATR, so quantification has reduced. But still, there are many times we are doing it. In pharma, there are few components where the regulatory says for quantitative, so for that they are using it. I'm just saying an application, quantification. It is possible, very well possible.
No, sir. If sorry.
Yeah.
If a liquid sample, if you are targeting for a quantification, how you will do calibration with the instruments?
So calibration is one thing, is you can change the concentration.
Okay.
So different concentration liquid cells, there are different cells are available. So you can inject with a different concentration, find a plot. Calibration.
This is based upon how dilution will make for the different concentration.
Yeah, dilution you can make.
The medium, water.
No, not water. See, if it is water, you can use, or main thing is a chloroform. Most of the time it is with chloroform. Because water, the problem is with the cell. Okay. Most of the time you will be using a NaCl or a KBr cell. So, but now with the latest technologies like zinc selenoid is available, or if you want to use it water, it is possible very well with the CIF2. Calcium fluoride cells, CIF2 cells are available. With that, you can make a different concentration.
Okay. Different concentration of what?
On the sample, on the standard. Standard, see, you can make a different standard. So, which compound you want to analyze?
No, sir. Actually, what our intent to understand is, we are a food laboratory.
We are keeping sample direct, but standard
It contains carbohydrate, fats, and protein. What standard? proteins content.
So if you whatever you want to quantify that, if you want to quantify the carbohydrates, then carbohydrates. That's done.
What's the carbohydrates?
Sir, it is exactly similar to UV absorbance. IR also, FTR, what you get in the transmitters mode, what we ultimately measure is the absorbance only. So, directly like UV, we plot a calibration curve. Exactly same way you make a standard solutions of different standard concentration, maybe 10 ppm. I mean, ppm may be difficult, IR may not be very sensitive for that, but maybe 100 ppm, 200 ppm like that. Make a calibration curve and then you put your sample and make it.
Sir,
It is exactly similar to UV.
That we understand, sir. But what we would like to express, as we are a food laboratory, we used to have liquid samples like beverages, like fruit-based, dairy-based, or water-based beverages would be there. That beverages contain different ingredients. Along with that, sugar would be there, color would be there. There are so many other molecules in there. Okay, along with the target element. So if you are making standard with the, as you said, chloroform or water, how exactly it will replicate that, medium
Of course,
of that
if you have
compound?
multi-components, if you have mixture, then definitely there will be interference because
Yeah.
ultimately the peak position is important.
That's what, sir. That
Whenever
is what
you
we would
calibrate the system for quantification, you have to measure at a particular peak, particular wavelength, whether it is UV or whether it is IR.
See, exactly UV you cannot get because UV signal is a very strong signal, whereas IR signal is a weak signal basically.
Yeah, that's
So
what-
the penetration is not as good as UV signal. So quantitative analysis when you are doing, fine. But when you are detecting something, accuracy will not be as good as UV.
That's what.
UV has a better. So ultimately, depending
Actually-
upon your analysis, you have to select the technique.
That's what, sir. Because the current standards for food is so stringent, but we have like less than 10 ppm for most of the elements. So in that case, how it will help us? That is what we.
You are saying that is a non-restricted technique. Actually, we are using this FPAR for mineral oil. So the thing we have to extract it and get the analyte. And the analyte we can make a calibration graph and compare it. Not directly putting on the food sample.
No, yeah. Directly if you put only you can get quantitative, qualitative.
Qualitative.
Qualitative analysis directly you can do. Quantitative if you want to do it again you have to definitely.
Qualitative analysis directly can be done provided the peaks are not interfering with it.
It does.
It all depends on the
That's
components.
different, sir, because that we cannot able to predict.
Yeah,
Because
good
many
point.
interference would be there inside.
Yeah.
Correct.
Okay.
Okay, we'll have for a break.
Thank you very much,
For a
Jagan.
tea and we can join.
Well,
Thank you, Doctor.
We can break for a small tea is available in the outside. We can have a tea and we can again join back for Dr. Gumathi's presentation.
yeah.